Hey everybody, so we're just going to do a quick little review of Chapter 11, Rational Expressions. So I'm going to start with some multiplying, dividing, and simplifying, just in case you want some extra practice before we go. This part of the final will be the second day. So we're going to simplify and find excluded values. We're going to multiply and simplify, divide and simplify, and then I'll probably make a second video for the add and subtract and simplify. So let's just a couple of things that you might want to put these into your note sheet if you're making one. So steps to simplify. You should always factor the numerator, denominator, or both if you can. So just always look at it. Is there something that I can factor on any of this? And then also put parentheses around any binomial that you don't factor, because otherwise you'll try to factor things or to cancel things that are illegal. And last but not least, simplify out your life factors. You do not have to multiply them back together at the end. So say, for example, you learned how to do this by using an app and taking pictures. That app probably taught you to multiply everything back in the end, but that is not what I want you to do. So let's look at this first one. It says 3x minus 6 and x squared plus x minus 6. So as I'm thinking through that, I want to look at the top. Now, do you notice the top has no x squared and it only has two pieces? So therefore, because it has no x squared and only two pieces, I'm going to think, what can I pull out of both 3x and negative 6? And so when I do that, I say, hey, there's a 3 and there's a 6. I can pull 3 out of both of those. So what I would do is write down the 3, and then what's left? X minus 2. And then I look at the bottom. Now, right away when I look at the bottom, I think x squared plus x minus 6. I'm just going to factor that. But do you see how there's a hint on the top? Because I know that to make negative 6, I could do 1 and 6 or 2 and 3. But since it says minus 2 on the top, that's probably going to tell me what's going to happen on the bottom. So, because it's an x squared, the form is ax squared plus bx plus c, I can just say, all right, what's going to make up the x? That would be x and x. What's going to make 6? Negative 6, but add to 1, I'm going to go with 3 and 2. I know the 3 has to be the positive one. The 2 has to be the negative one. Now I've got everything factored. So the steps, it said factor, the numerator, denominator, or both. I did that. Oh, now I'm going to write the excluded values first. So, in order to find the excluded values, I only care about the bottom. So I look right here, and I look right here. And you have to do that before, like the numbers, even if you cancel out the x minus 2 later, that still counts as an excluded value. So over here, I'm going to say x can't be equal to negative 3 right here, and positive 2. So it can't be negative 3, it can't be positive 2. Now that I've done that, I'm going to go in and say, okay, what can simplify out that x minus 2? So my final solution is 3 over x plus 3, and my excluded values are negative 3, positive 2. All right, now what happens if I have, this one says division, but I'm going to go to there first. Let's see. All right, I had a quick little snafu with the slideshow, but let's see here. Look, same slide, but I've got another equation or rational fraction over there. It says x squared minus 9x all over x squared minus 6x minus 27. So I look at the top. This time it does have an x squared, but do you see how it's just a binomial? That means there's two little pieces to it. So x squared minus 9x. There's no constant at the end. So I can't break this into a two parentheses, a binomial times a binomial like I can to the part below it. So I'm just going to look at x squared minus 9x and say, what can come out of both of those? Well, I know I see an x and an x. So right there and right there. So I'm going to pull out an x, and then what's left? Got it, x minus 9. So you are not, a lot of you probably were like, oh, x plus 3, x minus 3. To which I say, no, you can't do that. That is not right, because it's 9x, not just 9. So instead I would factor it into x times x minus 9. Then I look at the bottom. Do you see how there's three pieces? I've got an x squared and a constant at the end. So that is going to go into two separate parentheses, so a binomial times a binomial. So what gives you x squared? That would be x and x. What gives you 27 multiplies to negative 27, but adds to give you negative 6. I'm thinking 9 and 3. And the reason I thought 9 and 3 was, first of all, because I know my multiplication facts, but second, because look at, oh, hey, hint, 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 there's a 9 up there. So I'm going to guess that it's going to be minus 9, positive 3, and then check to make sure that that actually works. Okay, now, second, write your excluded values before you start simplifying stuff out. So when I do that, I'm going to look and say, all right, what goes here? What goes here? Well, I know that x can't be positive 9, nor can it be negative 3, because that would make the bottom equal to 0, which I don't want. Now I can go in and cancel stuff out. So the x minus 9's cancel, and I am left with x over x plus 3. Now, just a quick thought, if everything cancels on the top, it's super important that you still see something lives up there. A 1 is left up there kind of as a placeholder. Something else that you need to see, this x right here and this x cannot cancel each other, because this x plus 3, that's going to make that all not work. All right, now let's try some multiply. The first one is actually way simple, simply because there's no pluses or minuses, so I don't have to factor anything. I can just start simplifying. So I'm going to start here at the 8. Can the 8 cancel with anything? And I say, kind of, sort of, it can simplify. The 8 and the 12 can simplify. So over here, 8, what goes into both 8 and 12? 4 does. So I can divide by 4, and I get 2x to the 4th, and down here I get 3x to the 7th. Now some of you are thinking, hey, couldn't I have canceled those x's? To which I say, yeah, but not everybody sees that. So if you see it right away, do it right away. Then I'm going to go to the, I'm just going to take care of these 5s. Look at 5 and 5 gives me 1 and 1. Well, that's super nice. Now, I have to ultimately get everything over one line. I can't have a time sign in there in the end. So I know that my 2 and 3 are going to stay, because those can't cancel anymore. But then I've got x to the 4th over x to the 7th. Some of you see who wins by how much. Others of you need to just say, okay, x to the 4th looks like this. X to the 7th looks like this. And so what is actually going to simplify out of that? Look, I can cancel, 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 cancel. So I'm left with x to the 3rd on the bottom. That's your final answer. And you might say, hey, that looks crooked. Yeah, that's okay. You can just move that. Let's see if my thing will actually allow me. Look it, I can just move the 2 over. Now all is well. Now I'm going to go on to the lower one. Do you see that there's pluses and minuses? Because of the, actually just minuses in this case, there's some stuff that's going to need to be factored out. So I'm going to start right away looking at the 8x and the 4x. Generally, we cancel crooked. Not all the time. Sometimes it's just right up and down, but generally kind of crooked. So as I do this, I'm going to put out my lines. I see that 8x divided by 4x is 2 over 1. Because 8 divided by 4 is 2. X divided by x, these guys just cancel each other out, which is super nice. Now I want to take this part right here. Do you see it's 3x minus 2? There is no x squared, which means I can't break it into two binomials. I just look at it and think to myself, what comes out of both? So what does come out of both? Yep. Now what's left? X minus 4. That's going to give us a big hint down here. Do you see how you have an x squared and a minus 16? So look at the clock in your head. Whenever you see an x squared minus just a constant, generally it's going to be a perfect square. So I see 4 and 4. So that's going to be x plus 4, x minus 4. Now, if they ask you to find excluded values, up on the top, this one, x couldn't be 0, and you don't care about the 3, doesn't make any difference. Down here, x couldn't be -4 or +4, or 0 from right there. But I'm not sure if we'll actually ask you that on the final. It's just good to know. So now I'm going to take my purple and look across. 2, does 2 cancel anywhere? No, because I can't cancel into those x plus 4, x minus 4s. The 3 doesn't cancel, but look at x minus 4 and x minus 4 do. So now, what's on the top? I multiply them to get 6, and on the bottom, x plus 4 times 1 is just x plus 4. There you go, and all done. All right, last but not least, let's try a couple of dividing ones. Just one. All right, this, when you're dividing rational expressions, dividing any kind of fraction, you keep the first one, you switch your division, and then you flip these guys. All right, so I'm going to rewrite that all as x squared minus 25 over x minus 3. Put a parentheses around that because you can't fix it yet. Then make it into a times. X plus 2 on the top, can't simplify that yet, and x minus 5. Now, you'll notice I put parentheses around 3 of them, but not this one, because that, it says x squared minus 25. What do you know about 25? Yes, you know it's a perfect square. So I'm going to take this and rewrite it. All right, now on the bottom, I've got x minus 3. Up here, I'm going to take out the times sign because I really don't need it. X plus 2, x minus 5. Okay, so now I look here. Does x plus 5 simplify? Nope. Does x minus 5 simplify? You bet it does. X plus 2, x minus 3? Nope. So how do I write my final solution? I just write it as x plus 5 times x plus 2 all over, not 2a, that's a different question. There it is. All done. It's a beautiful thing. All right, next video, we'll do a couple of adding and subtracting ones.